Sammy, please tell us how to make matchbox rockets.
Well, first you take this template and use this aluminum foil tape to cut out a square for the fin where it says on the template.
Okay, Sam, after you have cut your piece of tape out, what do you do?
Well, you fold the both ends of the tape together to form a triangle. Once you use the tape, you get this as your final product. This is going to be the fin of the rocket that we're going to launch.
What is the fin used for, Sam?
The purpose of the fins of a rocket is to provide stability, so like the rocket can like go fly like good.
Okay, Sammy, what is our next step in the rocket building process?
Well, you use this template to get a piece of foil. Use this template to cut out a piece that looks like that.
So exactly alike.
Yes.
Three.
You put this foil, you cut out, you put it away off to the side, and you grab a match, and you cut the head of a match off like this. It's gonna look like this, and that's gonna be for later use of the rocket. This is where you take back your piece of foil that you cut out, and then you get a skewer, and you put it right here, and then you get your match head that you cut, and you put it right there. Right there. And then this is where you start rolling. After you've rolled the foil on your skewer, you want to take this area that you left between the match head and the rest of the foil. You want to pinch it. You want to pinch it to make sure that it gets sealed up. So. And then you fold the foil to make sure that air doesn't get out. Your final product of the rocket should look like this. And now we're gonna go launch this. The reason why the rocket took off like it did is because the single match head that's wrapped in foil, it combusted when you applied heat with the candle. So when it blew up inside, it forced itself off of the stick. And this force is called thrust. Thrust is just basically the force for the rocket to take off from its starting position. The way a rocket moves and lands can be defined by Newton's 3 laws of motion. Newton's first law states an object at rest will remain at rest unless acted on by an unbalanced force. The rocket, for example, stayed on the stick until an unbalanced force was applied to it, being the head of the match that's within the rocket. This force was applied and it made the rocket propel off of the stick and go into motion. Newton's second law states acceleration is produced when a force acts on a mass. The greater the mass, the greater amount of force that it is needed. Going back to the matchbox rocket example, since the rocket was a lightweight rocket, not that much force was needed for it to propel off of the stick, unlike an actual rocket that needs a much greater force since it has a greater mass. The final law of motion states that for every action there is an equal and opposite reaction. So for our matchbox rockets, our action was the combustion of the match head within the rocket, and the reaction was the rocket actually propelling off the stick and taking off into flight. The first true use of the rocket was actually dated in the 13th century when the Chinese started to experiment with gunpowder and fire to create fire arrows to use against their enemies in war. Today's world, we use rockets to travel to space, for defensive weapons, and even videos for chemistry class.